Hello, myself Deepesh Yadav, and I'm from Atair University, Bangalore. And this is my summation for the Altair Global Student Contest 2025. The problem statement for this summation for the project that I have done, that is like the stress plus emotion fusion using the Rapidminer AI Studio. And then this is like a predictive system for understanding the psychological and emotional state of a human being. Yeah. Okay, so the real challenge is like the today the people are suffering from the stress, emotion, prediction systems. They operate very independently. There is not something combined thing for the stress and the emotion, and this causes the fragmented interpretations and no unified understanding of the human state. So it's very difficult to identify whether the person is like the highest risk behavior or low risk behavioral person, and hard for the decision makers to interpret multiple models output. Yeah. So the main goal of this project was to create an one fused emotional, psychological, physiological state that combines uh, stress level and the emotion state into a single level that is easy to act upon. So that if I talk about the data set that I've chosen, uh, uh, it is like a stress detection data set, that is B side, and we used like this physiological data set, which is widely recognized data set for the stress research purposes, that collected with the sensor, and we have this sensor data included ACC accelerometer that detects the body movement, and then we have the EDA, the electro dermal activity, and state detectors, and BBP, blood volume pulse. It's for the cardiovascular responses, and then we have heartbeat for the physiological arousals, and then we have the IBI. It is like the interbeat interval. It's like the how we get the rhythm of heart. So you can see this is like table that this is like a more of a generalized thing that I here I added. I did some feature engineering from using the Altair AI Studio. So I converted the column of ACC into three like three directions, that is like x-axis, y-axis, and z-axis, and then I use this BBP, EDA, and HR, that's like heart rate, and IBI, and the subject is like the number of the subject that used that were used to collect the data set. And another data set is like emotion recognition data that I have taken from the Revdes, and use this Revdes voice emotion data set. It's like a professional audio data set containing the acted speech and the emotion. And this data set is a collection of 24 actors that come acted, and then we like collected the data of their voices. And so this data is carrying 8 emotions: neutral, calm, happy, sad, angry, fearful, disgust, and the surprised. So this is the column. This is like sample data set, you can see here. Yeah. And you can see the emotion level is like the neutral, and this emotion code is, and this actor, the which actor has acted, and the data is okay. Okay, if I talk about the solution, so I built a two pipeline AI system. That is, one is like the stress prediction model, and another is like emotion recognition model. So stress prediction model, I use like I'm using this physiological features to predict stress and confidence of the stress. And for the emotion recognition, I'm using this MFCC to predict emotion level, emotion prediction. And then after doing this, getting the two pipelines, I'm fusing them. The fusion engine in the rapid manner. This like aligns the prediction, joins the data set from both the pipelines, and based on the rules that I have defined to predict whether the person is high alert or medium alert needed or relaxed or the mixed state, something like that. Okay, so you can see here, this is the pipeline that I've created on the Altair AI Studio, the Rapidminer. So you can see this is the stress detection pipeline, and this is, I'm just calling it a process one. And you can see here I'm reading the CSV and generating a columns, and these are the simple operators that I used, and this is the loop value inside this. There is an other set of instructions that I've been given, and after doing this, I'm just setting the role of the dependent model, like dependent variable that need to be predicted. And here I'm just splitting the data into test and train sets. And this is the deep learning model. I'm using deep learning model neurons to predict the stress. uh, okay, so I'm just applying the model, and here you can see I, as of now, I have selected this select attribute, because like in the process I will be using this the attributes from this trend model. And the performance, this is the performance. I got the accuracy of 95.7% accuracy. And yeah. Okay, so this is the another pipeline that is I'm calling it a process two. Here also I'm this selecting the reading this the data from CSV with the read CSV operator and the generate ID. Then I'm selecting the column. Then I'm checking and replacing the machine values with the mean, and I'm setting the role of the dependent model as the label, and then I'm normalizing it. Okay, and here I'm normalizing it because like the data is very low, like low level high level value, so it's like it needed to normalize the data. And here also I'm doing this splitting of 70/30 training test, and I'm using the deep learning model. And with the apply model operator, I'm just uh, after training I'm applying the model and to get the performance of the uh, pipeline. And you can see this is the performance. Okay, the performance is like accuracy is 65.97. Yeah. So this is the fusion of the both pipelines. I earlier told like the process one, process two. This is the stress process, and this is the emotion process. Here I'm sorting it the column based on the ID. And so I'm just joining using a join operator and performing inner join on the ID column. Okay, so here you can see I use select attribute to select the column and then rename the column for the better understanding. And here I'm generating another column that is fused state column, and I'm assigning giving some rule based fusion formula. So this is the formula that I've used. Yeah, it is like this platform you can write like formula to set your rules based on the how on what basis you are generating a new attribute in the data set. And this is the formula that I have used, and it's more of rule based. Yeah, I just written this formula, and I generated a column fused state, and then I selected, and you can see the results here. This is the result that I got on the final output from the fusion result by fusing the both the pipelines. And you can see the stress, if the stress is here stressed, and this emotion is neutral, and it's predicted as a calm. So it's not the accurate prediction here in this row, but you can see the rest of here, like if the stress is mild and this prediction state is also mild, and this emotion level, it was happy and it predicted as a happy. So if it is mild and happy, then state of the human being will be mixed. Okay, and if it is mild and sad, then it will be of medium alert. Yeah, thank you. And now I can show you the how I work on this pipeline on the AI Altair AI Studio. So you can see here, uh, this is my okay, so this is the stress detection pipeline. So here I have used this generate okay, the CSV. This is the CSV operator. You from here we can get the operators. There are lot many operators. It supports lot many features, and here I use this generate ID and this like parameter setter. You can set the different parameters, and yeah, so I use this path for the CSV file, and this generating the ID. Yeah, I'm using the generating a ID for this, and this is filter example. It is like adding a custom filter. This the x-axis, or you can select from here. Okay, and then replacing the missing value. Here it is by default giving the average. If value is missing, then it will do the average of that column and impute that value. And here you can see this is the loop values. And here if you go inside this, there is another pipeline. Here we are setting the example. Here also the same the columns are given, and this like we are creating a simple what we can say, it's a kind of filter to say it is like equal, and then the subject name, so that later when we are using this in pipeline, it will be really helpful for that. And here we are selecting the column. If you want to select the multiple columns, and select this set, and then you can select the set of columns. Here I am selecting these many columns, and so here generating the attribute. In this operator I'm generating the attribute. It is stress, yeah, stress, and this is the formula, that function. Here we can write the expression to, it's a kind of rule, the formula that we write on what basis we are creating another column. So it's like this is the inside the loop. And let's come to the server of this process. uh, let's here it's appending. Let's append the parameter that operator when using, and it's like setting the rules inside this. This stress is the my label, the target role. So I'm just giving stress as a target role, and target variable, and here the prediction. So as of now, I'm using the 70%, 30%, 70 for the training and 30 for the testing. Okay, this is the the deep learning model. And so this is the activation function rectifier with dropout, and you can see the number of epochs I'm using 10, and this the train sample per iteration -2, and the RHO is rho is 0.9. I'm using that as of now, and L2 and this L2 and L1 norms, and loss function is there. So you can manipulate based on your need, and yeah. So after this I'm just applying this model, apply model on this deep learning, and I'm connecting this test. I'm training this model on the train. This is for the train, and it's going to the apply model, and here I'm testing this model, applied model, on the test set. And as of now I'm selecting this stress. If I want to run this, then you can see performance also. I okay. So yeah, selecting after this, selecting this, yeah, save the changes. I will come to this emotion pipeline. Yeah, it is like this, selecting this CSV file into it and generating the ID. And you can see here, this is parameter setter. Generate the ID. Yeah, it will generate ID for this unique set of column, a column that is ID. Okay, here this selecting the column that we are going to work with. So these are the column that I selected. Yeah, it is like the data set was very high features data set. The number of features very high. So I merged the data set. It was like multiple WAP file was there. So I merged the data set and got these features. So I selected these features, and not this the ID, file name, and the emotion, because they are not needed for our use case. And here also I am using this replace missing value operator, and just replacing the missing values with the average, and setting the role. What will be the role? So here the emotion label is my the target variable. I am giving it as a label role, and you can give as per your use case. And here normalizing the data based on this jet transformation method, I'm using this to normalize the data. And here the split data it of the random, yeah, local random seed is 42 I've given. And it's like the partitioning again I have given 70%, 30% trend test. And again I am applying the deep learning model. Yeah, so with this, yeah, there are like it supports this the Altair Studio support the deep learning kind of modeling also, not only the traditional machine learning model algorithms such as like the linear regression or logistic or the classification or this decision tree random forest. Not only those algorithm, it also supports the deep learning based models. So yeah, I experimented with this model. It's giving quite good results. And you can see here. Okay, so if I deselect this model and this operator, and I can search for the performance. Here you can get the performance classification. Yeah, this one you have to simply drop and drop, drag and drop here, and this connected with a table here to here, and then performance to the results, and you can run the pipeline. So you can see here the model is training, the deep learning model is training. It's taking a bit time. No worry. So yeah, you after this you will see the results. And here I have stored my the data here. I created a separate folder for the Altair processes, and these are my three processes that I have done. And this is the data that I have stored, the RapDes data, and this is the vset data with the merged all CSV files because it's a huge data. So I merged into one CSV and imported that data. So yeah, there is feature of looping also. If like there are multiple CSV files, then we can loop those files into one process. So that is easy, and like you can do that also. But in my use case, I thought to use this merging thing. So I merged with the Python in the VS Code. So and then I use this merge CSV file into this system. And yeah, I got this file and this file. The other two files. Yeah, you can see the model is trained, and this is, yeah, model is trained, and the performance is given here. You can see from the results. This is the performance. It's giving 65.97 accuracy as of now. And you can see this, the performance vectors, the true, and this natural, neutral, sorry, calm, happy, and these are the also, it's like confusion matrix is given. And yeah, you can see the performance here. And so this is the turbo preparation, and like its auto model is there. You can see here. I've already did this for this pipeline. So you can see the predictions performance. For the naive based performance, it is giving 72.7% with a standard deviation of plus minus 0.2. Classification is error 23.3. With things need to improved, need to be improved. And these are the models that you can use here before doing that. And so here only you can select the models. Like if I'm deselecting this, no needs of this model. Deep learning I have already done, so it's quite easy if you distill less number of models then run. So yeah, this auto model, rather than going with that creating the pipeline, that is a kind of method also. And this is also a kind of method only. It's a way, functionalities are very nice. And you can see from loading the data set to the creating the model, predicting, training the model. Here are models, both the models are getting trained. And here you can use multiple models to train the data set and to see the results. Okay, so it's my model is training here. And okay, so these are the two models that I have selected, and these are the indicators like the model, the simulator is there, the performance. You can see the performance of the model on the particular use case, and the predictions in the prediction model. So these are the things that it gives. Yeah, so let's see. These are the two models you can see here. and it will show the gains and the total time taken to train the particular model on the dataset, and its training time and the scoring time is given. Yeah, so let's stop this here. It's taking so much time. We can take, as of now, we can reduce the number of this, and let's try to run this model. So it will give some results. It's training. Till the time you can see other functionalities of this. And these are the two pipelines that I've created, and yeah, and this is, here are the operators. You can see different operators are there to work on, and NiPS is taking too much time to train. Yeah, you can see. Now we got the results. Uh, yeah, so accuracy is 72.7%, the NiPS, and the classification is error 27.3, and this is prediction state. This confusion matrix is given, and the standard deviation is here, and you can see the so cost. So this is the trusted stress. You can see here cost of for the wrong predictions. It's it predicted the true calm, but it's true calm. It predicted calm, so its score is +1. If it is true stress and predicted the calm is -1. So it's like the kind of confusion matrix only, not exact confusion matrix, but here it's we call it a cost matrix. How much we cost? If it is like true calm is there and it predicted mild, so we are just going with the negative -1, and it is a true mild and it also predicted the true mild, so we are going with the +1, so it's fair enough. So this is how like we can go with this the results you can see, and yeah, this is the result for this pipeline, and this is for the emotion pipeline, and the accuracy 65.97, and this is okay, where is okay. Yeah, so yeah, this is the process that I have done, and let's see the fusion thing. This is I like this fusion thing because like it's good, and here I haven't applied this. I have to remove this, so I have to deactivate this again, so that our pipeline is ready, because of that fusion thing will take the process and the columns. Yeah, now you can see here in the fusion also. No, yeah, now you can see it's not giving any error. Okay, thank you.